One hydrogen atom from your alkane is being replaced by another halogen atom. So what happens? This will become CH3. The halogen is attached to a carbon which is adjacent to a double bond which is present. In alkyl halides, the halogen atom is bonded to an alkyl group. Okay, they form a homologous series represented by CnH2n plus 1x. Hello everyone, this is Ambali Unnikrishnan from the Department of Chemistry. So today we are back with a new chapter, that is Haloalkanes and Haloarenes. So this is the first chapter of organic chemistry from your class 12 syllabus. Right, so we are going to start with a new chapter today. Right, so in today's session we are going to see the introduction to haloalkanes and haloarenes. So you already have an idea about what is organic chemistry, right? And the basics of organic chemistry you have already studied in class 11 also, right? Even the nomenclature also you have studied, and some reactions as well. So now in detail we are going to study about different functional groups and different compounds as different chapters in class 12. Okay, so the first one we are going to study is haloalkanes and haloarenes. Then you will have aldehydes and ketones, carboxylic acid, alcohols, phenols, ethers. All of that we are going to study in the upcoming chapters. Right, so the introduction to haloalkanes and haloarenes. What are haloalkanes and haloarenes? First we need to understand, right? And then we'll be studying about the classification of haloalkanes and haloarenes, the classification of monohalo compounds, then compound containing sp3 carbon X bond. Now what is this X which I have written here? We'll understand that. And compounds containing sp2 hybridized carbon and X bond. So that X actually stands for, as you can see here, fluorine, chlorine, bromine, iodine. Those are the halogens, right? And classification of dihaloalkanes. So all this we are going to discuss in this session today, right? So as you can see, first of all, the chapter name itself says it is haloalkanes and haloarenes, right? Haloalkanes, haloarenes. So from the name itself, there are few things that you can understand, right? So this halo is common in both. So what does this halo stands for? Halo stands for halogen, right? Halo stands for halogen. So you're already familiar with what is halogen or what are the halogens, right? So they belong to the 17th group, right? And those are fluorine, chlorine, bromine, iodine, right? So these halogens, okay? So the halo stands for halogen. Now alkanes you have already studied in hydrocarbons chapter, right? About alkanes, right? So what does then haloalkanes means? It is somewhere a combination of a halogen and an alkane, right? As of now you can tell like that. Now what will be haloarenes? It will be a combination of halogen and arenes, right? So this is the basic idea about it. Now let's see. The replacement of hydrogen atom in hydrocarbon, aliphatic or aromatic by halogen atom results in the formation of alkyl halide, which is called as haloalkane, and aryl halide, which is called as haloarene respectively. So how do we obtain a haloalkane or haloarene is what is written in this sentence. For example, let us take the simplest alkane, CH4. This is an alkane, we already know that, which is, what is the name of this? It is called as methane. Only one carbon atom is there, so it is called as methane, right? So how do we obtain a haloalkane? Okay, or else another name for it is, as you can see here, another name for haloalkane is alkyl halide. Okay, alkyl stands for, we are going to discuss. So another name for it is alkyl halide. So what does that mean? The replacement of hydrogen atom in hydrocarbon, whether it is aliphatic or aromatic, by halogen atom. So one hydrogen atom from your alkane is being replaced by another halogen atom. So what happens? This will become CH3. Right, one hydrogen atom is replaced. Instead of the fourth hydrogen, a halogen atom will be replaced. For example, I am taking Cl here. Okay, so this is your haloalkane. Yes, this is your halo, this is your alkane. From which alkane it is derived? From methane, right? So this is your haloalkane or alkyl halide. It is also called as alkyl halide. So CH3, it is called as alkyl, right? So which alkyl group is this? It is methyl group, right? So this is your alkyl halide. So in the same way, from an arene, if a hydrogen atom is being replaced, okay, and substituted by another halogen atom, it becomes haloarene. Okay, another name for it is, yes, aryl halide. So alkyl halide, aryl halide. So I hope it is clear. This is the basics of haloalkane and haloarene. So I hope how it is obtained is clear for you. So that is very important to understand. From your alkane or your aromatic group, what happens? One hydrogen atom will be replaced by another halogen atom. So it is not necessary it is chlorine. It can be any other halogen atom. So in general, how do we represent it? R stands for any alkyl group. Okay, or any aryl group also. There are haloalkanes and haloarenes, right? So it stands for any alkyl group or aryl group. And what happens? X is written here. So this X stands for whichever halogen is being replaced, right? So this can be fluorine, this can be chlorine, this can be bromine or iodine. So as you can see here, Rx is the general representation of an alkyl halide or aryl halide. So R stands for the alkyl or aryl group, X stands for the halogen. Now moving on to the classification of haloalkanes and haloarenes. Okay, so the first classification we are going to see is on basis of the number of halogen atoms. So how many number of halogen atoms has been replaced? So how many number of halogen atoms are present in the compound? Based on that, we can classify. So these may be classified as mono, di or tri or polyhalogen. That is, poly means if it is more than 2, we can say tri, tetra, penta accordingly, right? Compounds depending on whether they contain 1, 2 or more halogen atoms in their structures. So for example, first one is monohaloalkane. So what is monohaloalkane? In that haloalkane, only one halogen atom will be there, right? So as you can see here, C2H5X is given here. So this X stands for halogen, right? So it has been derived from C2H6, which is ethane, right? So instead of this hydrogen atom, only one halogen atom is being replaced and you get C2H5X, right? So this is ethyl halide, okay? So whichever halogen atom comes there, right? Now another one is dihaloalkane. Now what is dihaloalkane? 2 halogen atoms will be present. 2 hydrogen atoms are replaced by 2 halogen atoms. So CH2X and CH2X, you can see here, 2 halogen atoms are present. Now if it is 3 halogen atoms, as you can see here, 3 halogen atoms present, it is called as trihaloalkane. Further, we can call it as tetra, pentahaloalkane, right? Now in the case of arenes also, this is a benzene structure in which one hydrogen atom is being replaced by a halogen atom. So this becomes monohaloarene, right? Monohaloarene. Now this will be dihaloarene. 2 halogen atoms are present. Now this will be trihaloarene. So this is how the first classification is done based on the number of halogen atoms present in the compound. So I hope it is clear. So it can be mono, di, tri, tetra based on the number of halogen atoms present. So it is called as monohaloarene or monohaloalkane, based on whether it is an alkane or arene, right? Now the next classification is classification of monohalo compounds. So just now we discussed mono, di, tri, etc., right? So in detail we are going to see about monohalo compounds, right? So that means from here itself you can understand only one halogen atoms will be there, right? So it is classified majorly into 2 types, compound containing sp3 hybridized carbon halogen bond, sp3 hybridized. So hybridization we have already studied in class 11, right? And the compounds containing sp2 carbon halogen bond, okay? So it can be either sp3 carbon or sp2 carbon. Now the sp3 carbon halogen bond is further divided into alkyl halides or haloalkanes, right? And then you have allylic halides, benzylic halides. Now sp2 carbon halogen bond is classified into vinylic and aryl halides. So each of them in detail we are going to study now. Okay. So the first one is alkyl halide or haloalkane. So what is alkyl halide or haloalkane? In alkyl halides, the halogen atom is bonded to an alkyl group. Okay, they form a homologous series represented by CnH2n plus 1x. So for alkane, we know the general formula, it is CnH2n plus 2. Okay, so here you can see it is +1 because instead of one hydrogen atom, there is another halogen atom which is present. Okay, so this is also a homologous series. They are further classified as primary, secondary or tertiary according to the nature of carbon to which the halogen is attached. Okay, so the first classification is aryl halides or haloalkanes, which we were discussing till now, right? So that means the halogen atom is attached to an alkyl group. Okay, so that alkyl group will contain, of course, a carbon atom which will be sp3 hybridized, right? So this is the first one further, which is classified into primary. So what does primary mean? This is your halogen atom, right? Halogen atom is attached to a carbon atom, okay, which is part of an alkyl group, right? This much part is your alkyl group and this is your halogen. So the halogen is attached to this particular carbon atom, which is further attached to how many carbon atoms? Only one. So this R dash is actually what? Another alkyl group, right? Which also contains carbon atom. So this is how you have to see. If it is further attached to only one carbon atom, this will be primary. Now the secondary, this is your halogen atom which is attached to this carbon atom. Now this carbon atom is further attached to how many other carbon atoms? 1 and 2. Hence it becomes a secondary haloalkane. I hope it is clear. Now this is the halogen atom which is attached to this carbon atom, which is further attached to 1, 2 and 3 carbon atoms. So this is called as tertiary haloalkane. I hope it is clear. So don't be confused with the R which is written there. It is for the other alkyl groups. It can be any alkyl groups. Okay. What are alkyl groups? It can be CH3, C2H5, it can be C3H7, any alkyl groups. Okay. Which is derived from their respective alkanes. Okay. So according to how many alkyl groups are present, we can classify it as primary, secondary or tertiary. And in all these cases, okay, in primary, secondary or tertiary, in all these cases, the carbon is sp3 hybridized only, right? So how we can say a carbon atom is sp3 hybridized? The carbon atom will be further attached to 4 different atoms, right? So as you can see here, this is the carbon atom 1, 2, 3, 4. It is attached to further 4 other atoms. So it is sp3 hybridized. Here also 4 further atoms. So it is sp3. There also it is sp3. So this is the first classification, that is haloalkanes or aryl halides, which is further classified into primary, secondary, tertiary. Okay. So the next classification under sp3 hybridized carbon is allylic halides. Now, what are allylic halides? This is a new term for you. These are the compounds in which the halogen atom is bonded to an sp3 hybridized carbon atom next to a carbon-carbon double bond to an allylic carbon. So, what does that mean? So, from this particular compound, let's understand. This is your halogen atom. The halogen is attached to a carbon which is adjacent to a double bond which is present. Okay, so as you can see here, it is bonded to an sp3 hybridized carbon next to a carbon-carbon double bond. It is not directly attached to the carbon-carbon double bond. The halogen is here, it is attached to a carbon which is next to a carbon-carbon double bond. So I hope it is clear. Now moving on to the next example. From this example easily you can understand. The double bond is present here. Here is a carbon atom, here is another carbon atom. The double bond is present here. But the halogen atom is attached to this particular carbon atom which is next to the carbon atom which is a part of the double bond. Okay. So that means if for example, if the double bond is here and the halogen atom is attached here, that doesn't become an allylic carbon or allylic halide. Why that is not an allylic halide? See, the double bond is present in this carbon and this carbon. So to this carbon, if the halogen is attached, that is not allylic. To the adjacent one, the halogen should be present here, not here. It should be present here. Then it becomes an allylic carbon and allylic halide. So I hope it is clear. Now the next one is benzylic halide. These are the compounds in which the halogen atom is bonded to an sp3 hybridized carbon next to an aromatic ring. It will be attached to a carbon which is next to an aromatic ring. You can take this example. This is an aromatic ring which is benzene, right? So to this benzene, a carbon atom is attached. To that carbon atom, halogen is attached. Okay, so I hope it is clear. This halogen is directly not a part of this aromatic ring. The halogen is attached to a carbon atom, sp3 hybridized carbon atom, which is attached to the benzene. So this is called as benzyl halide. Okay, so here also it can be primary, secondary or tertiary based on the alkyl groups which is present. So this is an example of a tertiary benzyl halide. Why? The carbon atom in this junction, actually there is a carbon atom which is present, right? So halogen is attached to this carbon atom, which is further attached to one alkyl group, second alkyl group, and the third whole aryl group is there. So basically 3 carbon atoms it is further attached. So this is a tertiary benzyl halide, and this is an example of a primary benzyl halide. So I hope it is clear. So these were the classification based on sp3 hybridized carbon. Now moving on to compounds containing sp2 hybridized carbon halogen bond. Okay, so the first type is vinylic halides. So these are the compounds in which the halogen atom is bonded to an sp2 hybridized carbon of a carbon-carbon double bond. So now the halogen atom is directly attached to the carbon atom, which is a part of the carbon-carbon double bond. So you can see here the double bond is present in this carbon atom and this carbon atom, and the halogen is directly attached to the carbon atom, which is part of a double bond. So now I hope the difference between an allylic halide and a vinylic halide is clear. So this is vinylic halide. It is directly attached to the carbon having the double bond, and if it has to be allylic, it should be either here or it can be here also. Okay, so it should do the carbon atom adjacent to the double bond, not on that carbon atom, right? So here also you can see the carbon-carbon double bond is present here. The iodine is, that is the halogen atom, is directly attached to the carbon atom, which is a part of the double bond, right? The next type is aryl halides. These are the compounds in which the halogen atom is bonded to the sp2 hybridized carbon of an aromatic ring. To the aromatic ring, of course, all the carbon atoms will be sp2 hybridized. To that, it is directly attached. So you can see here. So this is the aromatic ring. Which aromatic ring it is? It is benzene, right? So to this benzene, directly the halogen atom is attached. Okay, so this is called as aryl halide. Now what is the difference between aryl halide and benzyl halide? In benzyl halide, how did we see that? So the double bond will be here and you will have a CH2X here. Right, so this is the difference. The halogen is attached to this carbon, which is attached to the benzene. The halogen is directly attached to the carbon containing benzene. Right, that is a carbon which is a part of the benzene itself. Okay, so these are the examples. So you can see further in benzene, other attachments or other constituent groups can also be present. Clear? So this is called as aryl halides. So I hope the classification based on the hybridization is also clear for you. So if the carbon is sp3 hybridized, there are 3 types, that is alkyl halides, allylic halides and benzylic halides, and sp2 hybridized carbon, there is vinyl halide and aryl halides. So I hope the classification is clear and the differences is also clear for you. Right, now the classification of dihaloalkanes. So those classification till now which we had studied, that was based on monohaloalkanes, only one halogen were there. Now if it is a dihaloalkane, that means 2 halogen atoms, then the dihalo compounds are classified as geminal halides. That is, the halogen atoms are present on the same carbon atom. So how many halogen atoms are there? 2 halogen atoms, right? It is dihaloalkane. So those 2 halogens, both the halogens will be present on the same carbon atom. Then it will be called as a geminal halide. Now what is vicinal halide? Halogen atoms are present on the adjacent carbon atoms. So from the example itself, let's take CH3, CH, Cl2. So CH3 and you have CH to which the Cl is attached. Okay, CHCl2, I've just mentioned it like this. I've drawn the structure like this. So here it is a geminal halide. Why it is a geminal halide? To the same carbon atom, both the halogen atoms or both the chlorine atoms are being attached. So this is a dihaloalkane. Of course, 2 halogen atoms are there and both the halogens are present on the same carbon atom. Right. Now moving on to the next one, you can see CH2Cl, CH2Cl. This is one carbon atom. This is another carbon atom. So the dihalo, that is both the halogens are attached to the adjacent carbon atoms. Okay. It should come in the next carbon atom itself. Okay. So it should be adjacent also. Then it becomes a vicinal dihalide. Clear? Now in the next session, we are going to study about the nomenclature of haloalkanes and haloarenes. So already you have studied how to name organic compounds, IUPAC nomenclature in class 11. So using that basics itself, we are going to study about the nomenclature of haloalkanes and haloarenes. So I hope the concepts that we have covered in this session is clear for you. So that's all for today. Thank you.